In this first section of Chapter 1, we're going to look at properties of real numbers. So we're going to first define some of the different types of numbers that we see and work with. We're going to look at some of the things that we can do with numbers, so kind of looking more specifically at addition, multiplication, subtraction, division, some of those basic operations. And then the sample problems that we'll do will just be some pretty basic problems where all we have to do is a little bit of multiplication or division to convert units or rates. So first of all, there are different types of numbers. We'll break these down. There's different sets of numbers. You could think of lots of different numbers, I bet, an infinite amount of numbers. But we're going to look at some of the different types of numbers. The smallest set of numbers are called the natural numbers. The natural numbers are those that appear naturally on their own. And so when you look out in the real world, you might see one object, you might see two of something, you might see 3, 4, so on. And sometimes 0 gets to be included in those natural numbers. So the natural numbers are, you might also have called these the counting numbers. 0, 1, 2, 3, 4, 5, all of those whole numbers up to infinity, as large as you can think. The integers are just the whole numbers that include the negatives. So we would have everything prior to -2, -1, 0, 1, 2. So all the positive and negative whole numbers. Rational numbers, those are the numbers that can be written as a fraction. So in the word rational, we see ratio. So we should almost more so say rational instead of rational. But these are numbers that can be written as a fraction. So some A over B. So 1/2 is a rational number. 2/3, -11 over 17 is a rational number. All of the integers are also rational numbers. The number 2 is rational because we could write that as 2 over 1. That can be written as a ratio, as a fraction, so that's still rational. So we kind of have this, it'd be kind of like a Venn diagram where all of the natural numbers are integers, all of the integers are rational numbers. After the rational, we also have irrational. I think there's a typo there. That should be IRR. Irrational. Irrational numbers are any numbers that are not rational. So anything that we cannot write as a fraction. And so between these groups, these are completely distinct groups. There's no overlap between irrational numbers and rational numbers. If there's no overlap between irrational and rational, then that means there's no overlap between irrational and integers or natural numbers. So irrational numbers are a little bit tougher to think of, but numbers like pi are irrational. The square root of 2, or lots of different square roots of not even things, are irrational, or a number that we'll learn about later this year. E is like 2.718, and then a bunch of other stuff are irrational. Okay, so irrational are numbers that cannot be written as a fraction. And then real numbers are just all of these. Real numbers are any number that you could put on a number line from negative infinity to infinity. So we could plot the square root of 2 or pi on a number line between the whole numbers that it falls between. So any of these numbers, any number that you know of, is a real number. We will, this year, learn about non-real numbers. If something's not real, we call it imaginary. And so we will learn about something called imaginary numbers, but you can worry about that later. So all of these numbers, like I just said, we could put on a number line. So that'll be what you'll do in a couple of the examples, is just plot a number on a number line, be able to compare it to other real numbers. Plotting whole numbers, that'd be pretty simple to do. So what about plotting some other numbers that aren't whole numbers? So what if I wanted to plot a negative square root of 6 on a number line. I don't know exactly where negative square root of 6 is. I don't know what that is off the top of my head, but I know that the square root of 6 is going to be somewhere between 2 and 3, because 2 squared gets us to 4, 3 squared gets us to 9. So square root of 6 has to be somewhere between 2 and 3, but we're looking at the negative side of it. So negative square root of 6 is going to be somewhere between here. There's my negative square root of 6. That's all I expect you to do for these. Or 11 thirds. I don't know exactly where 11 thirds. It's harder to think of that. So if we do 11 divided by 3, that's going to be somewhere between, what, 3 and 4? Right? Because 9 divided by 3 is 3, 12 divided by 3 is 4, so 11 divided by 3 has got to be somewhere between. So it's going to be actually like 3 and 2/3. So about right there is going to be our 11 thirds. So to plot these, I think it's easiest to think of it in the decimal form to see where it falls compared to our whole numbers. So we're going to name some properties with the operations that we can do with all of our real numbers. And you probably know all of these properties, but maybe not by name. So we're going to define these, and I'll use these terms occasionally. The main ones you probably hear are commutative or distributive. You probably hear those properties more than any of the others, but it's good to know what we're allowed to do with numbers. So the first property is called closure, and that one just tells us that if we add two real numbers, or if we multiply two real numbers, we get a real number. So if we take two numbers on the number line, add or multiply them, we end up with a number that's on the real number line. It wouldn't make sense to get something that's not real. The commutative property allows values to commute when we add or subtract, or sorry, when we add or multiply. So if I take a plus b, that's the same thing as b plus a. Right? 2 plus 3 is the same as 3 plus 2. We can change the order of addition, or we can change the order of multiplication, and we get the same result. 2 times 3 is the same as 3 times 2. Now I cannot do that with subtraction or division. Right? 2 minus 3 is different than 3 minus 2. So note that these properties only apply to addition and multiplication. The associative property is very similar to commutative. Here if we do a plus b and then add c, that's the same as if we take a and add b plus c. In my opinion, that's almost the same thing as commutative. We're just changing the order that we're adding these numbers. And same for multiplication. A times b times c is equal to a times b times c. We're just changing the order that we're doing those. And that's okay. We get the same result. The next property is the identity property. So for addition, if we take a number and add 0, we get that number. So it's the identity because it stays the same, right? It's got the same value, the same identity. But for multiplication, if we multiply something by 1, we get the same value. The inverse, so the inverse of addition is subtraction. And we're actually going to define subtraction with addition. But the inverse property says that if we take a number and add the opposite of that number, we get 0. So adding the opposite is the inverse. And then for multiplication, if we take a value and multiply it by the reciprocal, so the reciprocal is when we flip the top and bottom of a fraction. If we multiply by the reciprocal, we get 1. Which kind of undoes that multiplication, right? And lastly, the distributive property is the one that you probably actually refer to, and you use that word the most. That's the case where we have a times b plus c, and we distribute that a to both terms. This is equal to a times b plus a times c. That's the property that we probably use the most. So in a few of the examples on the homework, you'll be given an equation and be told or asked to say which property does that demonstrate. So here we're going to define a couple terms. So the first is the opposite. If we're talking about the opposite of a number, that just means that we're switching the sign. So what's the opposite of a positive 6? A negative 6. What's the opposite of a negative 3? A positive 3. And so this is actually how we define subtraction. Subtraction is defined to be adding the opposite. So if I want to do 5 minus 2, that's defined to be 5 plus the opposite of 2. And the benefit of that is now we can use those properties we just looked at. Now, since we have addition, I could rearrange this and do negative 2 plus 5, and I could use that commutative property. I can't use the property or the commutative property straight from here, because if I change this to 2 minus 5, that's something different. So if we define our subtraction with addition, then we can move things around. And we can do the same thing for for division. Let's say I wanted to do 6 divided by 3. I can't switch that to 3 divided by 6, but the definition of division is multiplying by the reciprocal. So this is defined to be 6 times the reciprocal, so 1 over 3. And now we can use the properties and move things around. And 6 times a third is the same as 1/3 times 6. So just understand that addition and multiplication are kind of our two main operations, and then subtraction and division are kind of just specific cases of, or a rewording of addition and multiplication. So the only other examples that we'll do in this section will have to do with converting units, and I'm going to show you how I was taught to set these up. That keeps things nice and organized. So let's say we want to convert 40 miles per hour into feet per second. So I want to convert 45 miles per 1 hour, and I want to end up with feet per second. So that means I need to get rid of miles and end up with feet, and I need to get rid of hours and end up with seconds. So let's take care of the miles first. So how many feet are in 1 mile? There's 1 mile is 5,280 feet. So we're going to multiply by that ratio, by that conversion factor, because what happens there is we have miles divided by miles, and those cancel out. And if we were to just do what we have here, then we would be in the units of feet per hour. But we want to get rid of hours as well. So how many hours? 1 hour is how many seconds? Well, we could jump there with minutes. 1 hour is 60 minutes, and then 1 minute is 60 seconds. All right, so then our hours cancel out there, our minutes cancel out, and when we multiply across the top, so 45 times 5,280 times 1, and on the bottom we have 60 times 60, and that's going to be feet per second. When we multiply that out, we get 66 feet per second. So to do these conversions, just set up your, just figure out first what your conversion factor is, right? What's the ratio from one unit to the other, and then set those up so that your units are diagonal from each other and will cancel out to get the units that you want.